Welcome to the second part of the Mastering the Fundamentals of RESTful API Design course. This is the second part, which is the intermediate part of the course. My name is Farhad Eftekari and I'm the lecturer of this course. Before you start with the material, you should make sure that you registered and you have this course as your enrolled course in your system and portal. So make sure to go to this portal and do that if you haven't done that already. Here are some typographical conventions that we're going to use throughout the course. So you're going to encounter them at the bottom of each slides many times. So make sure to understand them. And as before, we also divided the material of the course into three different difficulty level. So for some students, they would like to just get familiar with some concepts. Some want to gain more and deeper knowledge in some areas. So it's up to you. And you're gonna notice them at the top of the slides here. So this is also the slide framework. You can see the title, difficulty level indicator, a slide number, the contents in the center, course name, section name, and those icons that we described. The content of this part would be first, we're gonna get familiar with API description languages, what is the usage of them and what is the limitations. What are API's responsibilities, API's properties. Then we're gonna get introduced to 4 different API styles: REST, SOAP, RPC, 8 OAS. And then we're gonna compare REST and SOAP together because they are the most common and used API styles that the developers are using, especially REST. And then we're gonna compare REST concept and HTTP concept, because in some cases, there are similarities with the namings and with the concepts, so it would be nice to understand and be familiar with them. Then we're gonna get introduced to resources, and then the status codes and URI, and then some naming tips for API-based URL, and then some API endpoint tips. Here are also some definitions with the terms that what are they stands for. You're going to meet them in the slides, so make sure to understand them. And you can always pause and play the slides. So I'm not going to waste some time by just doing some weird, awkward pauses. So it's up to you to be in charge of the process. All right, now let's get familiar with API description languages. Well, API description languages, it's their job to make it easier to describe APIs. When you're creating your project, you have to somehow provide appropriate details and concepts about your API, about the resources, about the endpoints, about the actions, and different kind of operations that you're doing with your resources. So that's why it's somehow a project for you to also use with these automated tools for some developers to also build their APIs. It's definitely you need to modify that. It's not like a at the end result, but it's something that you can work on with. And it's exactly like programming languages, which is human readable and machine readable. So it's not like APIs, which we are like creating to be used by humans. So that's also one advantage of them and makes it much easier for people to also read and communicate with each other, send them like these API description languages instead of like describing things over and over again. So in short, it's there for you to use to express what instead of how. What does it mean? It means that if drawing a picture is like telling what is being done instead of like what is the technical way of doing things. And there are 4 major API description languages: API Blueprint, Swagger, RAML, and Mastery IO Docs. Most of the times I see in the industry Swagger and RAML is being used, although API Blueprint is also kind of getting common. And there's also a course for mastering RESTful API modeling languages, RAML, as a 5-credit course where you can also enroll. Now let's see what is the usage of API description languages. So we have communication, documentation, repository and version control, content, contract negotiation, API implementation, discovery and simulation, which one by one we're gonna explain and talk about them. All right. In the first part of the course, we also talked about the importance of communication, that how is it essential and vital for developers, for consumers, that they sit together, they talk to make sure they are on the same page about different topics and different subjects related to the API. So it's a very important concept, and API description language also makes it much easier to let these groups of people somehow communicate with each other, because there's this language that everybody can understand. And then also by using API description language, you're also documenting your API. You are explaining the resources, you're explaining the endpoints, your base URL, everything about your API. So that's also a great way of documenting your API instead of like everybody writes in whatever style he or she would like to write. It's some sort of a universal, accepted, documented way of documenting APIs. And then also we can use it for repository and version control. So every time you change something about your API or throughout time you modify things and added new features or abilities to your API and API description language, you can also record it in the repository and in your version control, whether it's Git or SVN. You can also include that, and then to make sure you know what has been done before and what was the changes, and that would be also a great advantage. There's also a course, Mastering Version Control with Git, which you can also enroll and find out more about version control and Git. I truly recommend you, especially if you are a developer, especially if you're working in a group of people, group of developers. It's a vital and essential actually knowledge that you have to equip yourself with if you already did it before. We have the term named contract negotiation. So before our consumers, our API consumers, want to lay their hand on them, typically we have to make them wait for the whole API to be developed. But if we are using API description language, then we can let them to also start developing their applications, web applications, projects, and whatever they are working on, because it can be used as a blueprint. What is blueprint in these terms? It's like something that is acting like your API. It can return sample data. It can have exact resources you are using, exact endpoints you are using. So they can also easily work with this nice blueprint as API description language. Even the authentication and even this kind of stuff can be done inside of this contract first design way. So that's also a great fast way of working in a team. Let everybody start their job. Don't make them wait for your job to be finished. And of course, at the end, well, when the API got ready, they can also migrate to that and then make sure everything is like functioning and working well. But that's a huge time saver. And also for implementation, when you write a very nicely written API description project out of your API, then you can use that and convert, migrate some tools and generate a skeleton of your API by using this automatic generating API tools. So that's also a nice speed up process. Of course, after that, you need to modify things, you need to make sure everything is functioning well, but it's also gonna save a huge amount of time for you. And now there's another advantage and usage, which is discovery. So when they get this API description language, they see everything about your API. They see all the endpoints, they see all the resources, all the actions that can be done to your resources. So there is no hidden feature or ability. Well, you may say like, oh, it's cool, like I want to hide something from the developers. But why should you? Because at the end of the day, you're developing your API for them to use. So what's the point of hiding that? So they should know everything about your API. They should know, well, of course, I'm not talking about the username and password of your database. It's not going to be included there. So it's all about working with your API. So it's a great way to make them discover your API and work with that API. And they can use it as some sort of a guideline for that purpose. And then, as we discussed before, they can easily use this sample data to simulate what's happening and then work with those kind of data. Imagine you have like some resources, for instance, like your students' information. So you're returning them some list of information about the students, about their enrollments, about their courses. So they can create their nice user interface with that sample data. And then once your API got published and released, then they can migrate to that system and then exactly show the user with the same user interface the exact data instead of sample data. So that's also a very nice improvement and make the whole process faster. And of course, there are also some limitations about API description languages. Well, the behavior of the API, because it's not the API. It's like something that acts like an API. And then the design of backend connections, well, that's also, we can call it limitation, but to be honest, it's not a limitation because that's not the purpose. That's why it makes it much safe and easy for everyone to use and share this API description language. You really don't want to share your backend connections maybe in that way. And then there are also specifications of non-functional properties, which we later gonna also introduce more. Well, we got introduced before, but we're gonna go to details more. But with API description language, you cannot really go deep with these non-functional properties. Now let's see what are API responsibilities. Well, APIs, in many cases, they collect data. So they store information, whether it's from your users, whether it's from the inside of the application, and they format data. So they put it in a nicely written or formatted style of data. It's not just raw data. And they also deliver data because like in many cases you are like returning bunch of rows of information, single rows of information. It's up to your purpose of the applications or the exact endpoint, which we later going to be introduced to. And also they help you to secure your data because there's going to be some sort of authentication and validation to make sure everything is being transferred or sent to the authorized person, not like everybody that like have access as a public access. And also one thing about formatting data is also these validations and making sure your data is valid in a way. For instance, in many cases, you are storing users' email addresses. So you don't want anybody just write some text. You just want valid email addresses to be stored there. So also that's one of the points of formatting data. And there are different API properties, consumer-oriented. They're simple, clean and clear, easy to access, secure, performance-wise, reusable, and support all clients. So it's up to your API how much they actually go far with these properties. The APIs have the ability to provide these properties, but it's up to your development team and API designers to make sure all of these properties are being done in a very nicely way. And now let's get familiar with different API styles. As we discussed and mentioned them, we have REST, we have SOAP, we have RPC, and we have hate OAS. As I said also in the first part, it's up to you how you pronounce it. Some people pronounce it hate OAS, and some people pronounce it like HTS, like HDS, but HTS. I did some research and find out these two groups, but up to you. Of course, you can also call it HATEOAS, but up to you. There's no way of pronouncing it right or wrong. It's not like API. I'm very, once again, mentioning never ever call API API. It's like children's calling something or something. It's not developer way of saying it. It's API. Thanks for considering this again. Now let's talk about the most popular API style, which is REST. Well, REST stands for Representational State Transfer. Is an architectural style for services. Well, we have already HTTP as an infrastructure, and what REST does actually defines set of architectural constraints and agreements. Well, we call a service which somehow complies with this kind of constraints RESTful. So that's the name RESTful is coming from, and that's why the title of this course is also Mastering RESTful API Design. So we have already this HTTP based infrastructures, and REST is actually using these infrastructures in a very optimal way. So somehow REST job is like the base idea would be transferring the ideas that work well for the web and apply them to web services. Later we will be familiar with HTTP concepts, what are the concepts that REST actually is using, what are the similarities, and yeah. Here is also a nice introduction figure that you can see. There's a client and there's a server. We have some resources here in our backend side. So what client does is send a request to the server, to this address, and then tell them like, okay, bring me back the tasks. And what the server does is actually giving back the request with a response, and then giving the client back what it asked for. It was a very simple figure actually to describe how actually it works with REST. Now let's get briefly introduced to SOAP. SOAP actually is like calling a function in a application. So imagine you have a client and you have a server. What SOAP actually does is to call those functions. It's like these functions are inside of that application, but it's just a remote connection that you are like establishing and calling those functions, and then you're receiving the results. That was a very simple way of describing them. Here actually you can also see we have client here and we have server here. So what it does is also actually execute some function here, and then the data is being sent through SOAP connection here. So it's like this whole thing is exactly in the same application. Like I said, imagine you have a program and then you're calling the functions of the program. But thanks to internet or LAN, now we can have these remote connections and we can call those functions. And then we have RPC style, which stands for Remote Procedure Call. So the SOAP follows the same pattern actually, and it's exactly like the same pattern where you can see the procedure is being called from the local machine. But you can also find out more about the comparison of these services. We don't want to spend that much time on this concept because we want to mainly focus on REST API style, but there are tons of materials online where you can compare them and find what's happening or what's the comparison between them. As a web developer nowadays, of course, REST is more recommended, but for internal purposes, organizations sometimes also use RPC or SOAP as well. But like I said, there are tons of material where you can see. And here is also a figure for that. So then we also have this client and server here, and then with this RPC thread, a procedure is being called, and then the result is being back. And then we have hate OAS or HATES, which is some sort of additional constraint to REST as well, where you can also find more information here. So it's also the same style, but with some sort of a more dynamic features and abilities. And in many cases, also you encounter streaming services, whether it's like some live streaming shows or material is being transferred. It's a different actually scenario. It's not like this kind of API styles that we briefly got familiar with it. There are different actually protocols such as XMPP or WebSockets, which they establish some sort of a communication channel between a client and a server and just send the data according to the exact part of the data to the user. So that's how they can like make this stuff happen. They are not like having this kind of a REST connections and like, okay, give me this information. It's a totally different protocol and communication channel. Now let's briefly compare REST with SOAP. Well, for access, it's also very interesting and noticeable. When you want to make some data available as a service in SOAP, you should call a function, exactly like a program function, like get a students. But here you can see we have these endpoints, API endpoints, which we are calling the students and then this number. Imagine there's no number here, so we are getting all the students list. So there is one difference like here. And then we call SOAP as a heavyweight and then REST is a lightweight. Much smaller with the bandwidth and this kind of stuff. And then we can also bound SOAP to HTTP, TCP, UDP, and SMTP protocols. But we only can use REST as a HTTP protocol because the infrastructure of HTTP protocol is the reason that we are benefiting from REST API style. There's no way that we can like have this functionality on SMTP, which is like a mail protocol or the other ones. And then we briefly got introduced to REST as well. And as we talked, there are differences considering HTTP concept and REST concept. We have definitions of resources, representations, uniform HTTP interface, uniform resource identifier, and also for REST side, we have these concepts of resources, representations, uniform resource interfaces, which we're going to get familiar with them in more details. Now let's discuss the HTTP concepts in more details. We have a resource. Well, resource is an abstraction of an HTTP entity, for example, a website. So we have this resource available, and then we have representations, which basically is this kind of formats that we are like returning to the client as HTML, XML, or JSON files. We somehow are encoding a resource by using these representations and returning them. For instance, imagine you have a resource as your students, then you're bringing back a JSON file with the fields or XML with the required fields of that resource. Or in most of the cases, actually, when you are browsing around through websites, the web page is a resource and the representation is this HTML, which is being back to the browser of your computer, and you're like showing that piece of information as a HTML representation. Then we have uniform HTTP interface, which basically are these four main post, get, put, delete operations. Later you'll in more details get familiar with them. And then we have this uniform resource identifier or URI, which is the address of that resource. And then we also have resource and representation concept in REST as well, which is very familiar to HTTP concepts as well. Well, we have these data models as a resource, like students, enrollments, teachers, all of these models that can be considered as a resource. And then we can bring them back with the exact same ways, like JSON file or XML file. JSON actually way of like returning the JSON file necessarily, with the fields and everything related to that. And then we can also use this get, post, put, delete methods, which next slide you will be familiar with them. So basically, a post operation is operation to create a new resource. We are posting a new resource to that endpoint with the required information for the backend or server to create a resource with this information. Or we apply get method, then the get will read a resource, whether it's one single resource or an array of resources, which later we will be familiar with that as well. And then we can also apply put method, which is like updating a resource, or delete, which is, well, deleting a resource. So all of their names is nicely familiar, but this put is a bit different, or this post as well. But basically we are posting a new resource, or we are getting a resource, or we are putting a resource on the place of a previously created resource, or delete a resource. But they are very, very beneficial and powerful, and actually these four methods are the ones that actually make REST possible. Because most of the times we are like dealing with resources, and we are like applying some actions or operations to our resources, and then these four operations are quite important, whether you call them operations or methods or whatever. Now let's discuss application state and the resources state. Well, the application that is like working with a client, there should be some sort of a state being saved somewhere in order to for that application to understand what is the client, what is the user that is like communicating with that application, to create this communication channel between each other. So that's why this application states comes handy, because once you get connected to the website, there's this application state being created for your own purpose and for your own like web browser or app or whatever you're like using. So then the server knows who you are to send the information back and forth and create this communication channel. But server components are stateless in REST. It means that the server components itself doesn't have any state for themselves. And then we also have resource state. So then we are dealing with information inside of the API as a backend database or somewhere. These resources also have a state. You can get access to them, you can read them, you can write them, you can modify them or delete them. Just as here I wrote this example of email box for you. Imagine you have like emails in your email box. All of these resources have a state. Like if you read the email before, or it's an unread email, you should read it now. Usually when you go to mailboxes, these unread emails are the bold ones, and once you open them, they become read, and then their status also changed to read instead of unread. Alright, now we got to the very interesting part of the material, resources. Resources actually are the most important part of the APIs because, well, they are the bricks of our information. They are like the things that change, the things that we try to send to our users, to clients, to show them some information, let them change something, let them insert new records or delete some existing records. That's the whole, well, big part of the purpose of these APIs, to work with these models of information. If you're already familiar with object-oriented concept in programming, it's a very, very close concept to classes in programming. So try to learn them, try to, well, gain a deeper knowledge with them, because you deal with resources a lot throughout developing API, because most of the times there are these 4 different actions you need to actually apply on resources. So here you can see a user. There's a phone number of that user inside of our database, and our user wants to modify the phone number. So we want to delete the existing information as a resource inside of our database and then replace it with something new. There are 2 ways of doing that. We can either modify that row of information with put or put operation, or we can just delete the previous record, and then with post operation we can also insert a new record. But that was just an example of dealing with a resource. And we have different kind of resources. We have collection resources, instance resource, and controller resources, status resources, and then sub resources. They're very interesting concepts. Make sure to understand them. Very, very easy to actually learn. Nothing very complicated or difficult. The name of themselves are actually self-describing. So we have collection resources. In many cases, we have collections of information as our model. So we have students here, and then we are giving back all of our students, which are 2 here. So by using this endpoint, we know that API students is returning all of our students, which turn out to be 2 here, with the ID of 1 and then name of Julia, and then, or Julia in English, and then the ID of 2 and then name Romo. So our students model or resource has 2 fields or properties, ID and name. This is actually a JSON object here that you can see. And then we have instance resources, which is like one single resource. So here you can see students, and then here we have this query string here as a student ID. So by actually inserting 1 here, this students is being returned to the client. So here the ID is 1 and the name is Julia or Julia. And then we have controller resources or status resources. Here you can see you are applying some function here. So by calling this endpoint, we are closing the enrollment, and then this status is being returned to the client to make sure the job has been done. Because there's no way, if this status is not being returned, maybe application is down, maybe it's being stopped for some reasons. So we need to actually make sure application understood the call and did the action. So we are returning the status code here with 202, which is accepted. Later we will understand and get more about these status codes. For instance, 404 is not found. So if we call close enrollment 123, we need to send 404 to the client to say like, okay, there is no endpoint here with that name. But here you can see it was there, and then it got returned that, okay, got accepted, and then the job is done. Although it's a made-up endpoint, and I was just writing this stuff here, but a programmer needs to actually send this certain status codes as well. Then we have status resources. Sometimes it's just want to return some status. What's happening here? That would be all of the job actually. Or maybe it was better that I mentioned here, like, is enrollment closed, and then return something here as a status, because that seems like more like a something to be done here, like this controller resource. All right, and now finally we have sub resources. Then you can see here we have a students, and then inside of our students we have also grades. So you want to see like what are the grades that a student has been passed for this course and this course. So there are these resources inside of our resources as our sub-resources here. Most of the times there are relations between our resources. We have students, we have courses, we have course enrollments. We have many actually models and resources actually connected together to make sure the functionality of the application is like in the right place. So this kind of a sub-resourcing and like resources are like kind of in many cases happen. So make sure to understand them and get the best out of them while you're developing an API. Actually, there are practices also to design our resources. First of all, no redundancy, no internal data, and then no composite resources. So make sure to apply them while you're designing your resources, properties, fields, the connections between them. All right, now let's talk about the status codes. When you are sending your request to the server alongside with the data is also returning a status code to make sure the communication is being done in a perfect way. Whether it was a failure, whether it was a success, or whatever it was, there is a proper status code to be returned to the client from the server. We have one something a status codes which for like informational. Here you can see you don't need to actually memorize them. There are some very important ones which later I'm gonna list all of them. Those are the ones that actually would be nice for a developer to understand and memorize, but not the other. You can easily check them. You can easily, like most of the cases when you're like developing your API, you can look them up and you can just use them. It's not a history class. It's like just would be nice for you to know there are these status codes which later you can use and use it with direct communications and these kind of purposes. And then we have success status codes which starts with 2. As you can see, there are like 3 digits, and the first one, which is 2 here, it's a group of success status codes. This one is very important. This one is important because once you post once you actually use this post operation, it would be nice that the server retain 201 status code that tell the client that, okay, I created this resource for you. Of course, it's not something automatic that has been created. It's not mandatory, but it's a great practice to do. Well, it's mandatory in a way. You should do it, but if you don't do it, you're not gonna break anything. Well, of course, it's like somebody tell you, go and bring me water, and then you bring the water and put it on the table. It would be nice to say like, okay, here's your water, or here you are. So it's like this communication that matters in developing an applications. And sometimes clients would also go through another measurement to make sure their status code was proper. Otherwise, they will like keep sending this request to make sure the server received it, and then waiting for the status code to be actually returned to them. And then we have 3 something, which is redirection, and then is 3 or 4 is like important, not modified. And definitely you encounter 4 or 4 not found before on like browsing on the internet, going through websites or pages. Almost everyone know that, even the non-developer people. So yeah, and then we have 4 O and then the other ones, which is also these 5 ones are very important, especially 404. Here are the rest. then the other ones. As you can see, there are like many communication messages that you can send to the client as a client error message. But like I said, these 5 ones are the most important ones, which you should always try to communicate if like the cases were like something related to them. So far, these guys were the most important ones. It's very obvious from their names that what they really mean. I don't need to explain any of them. And then we have server error, which starts with 5. It's recommended for you to like these server error codes, but do not show them to the client, especially if the client is a regular user. There's no need of like telling the user there was some internal server error. You can tell them like some mistakes happens, because you are somehow opening doors to unwanted information being shared. Sometimes maybe some clients, I don't know, they're like hackers, or some people want to take advantage of the system. So it would be it wouldn't be nice actually to show them what went wrong. What is the true error information of that part. Just show them, okay, something went wrong. We're working on it. Thanks for your patience. Try like a few minutes later or something, as you encounter many of like these kind of messages in the web as well. But of course, there were some websites showing you exactly what went wrong, which is not a good thing. And then here are the rest of these 5 something server errors. Alright, now let's discuss URI. Here you can see there's an example of URI, anatomy of them. So here we have the protocol, which could be HTTP or HTTPS, whether it's a secure connection or unsecure connection. Then we have the host as our domain name, and then the port, which most of the cases is 80. And then we have the path, and then some cases we have the query parameter. So this is the anatomy of a URI. Yeah, it would be actually nice to know that, of course, in most of the cases it's not going to happen, but still it would be nice for you to know in some servers and browsers, they can have up to 2000 characters here. So try to make them brief, or at least not more than 2000. And you should always consider, in my search engine optimization course, actually I explain this topic, that it would be nice to be something readable, because search engines really take the URIs seriously. It would be nice to mention something here. What's this information about? You can find out more about this stuff in search engine optimization course. And there are some recommendations what to do and what not to do actually. So when it comes to the URI, try to use only lowercase, try to use hyphens, not underscore, and try to use plural names. So here you can see courses, not course. Of course, it's not going to break anything, but it's a recommendation. And then do not use capital characters, no slash as the last character, because it may consider it as a directory, no underscore, no file extension, and no space or blank, because the space and blank will change to something weird like %20 something. I don't know. It's not very nicely readable thing to show to the user. Alright, now we have URI template actually. It's a recommendation here. Well, here you have your domain name, and then, well, API something, and then the version of the API you're offering, the namespace, resource, resource ID if you have sub-resource, and sub-resource ID. This is the type of the sub-resource, like grades, and this is like the type of resource, like the students. So this is a recommended template for URI. Of course, you can replace them however you want, but this is a nice recommendation that most of the people and developers are following actually. And you should always consider this point, that do not change your URI once you offer them to your consumers. It's gonna break the whole API, and it's not gonna break the whole API. It's gonna break the application actually that they created to communicate and work with your API. And well, if you really have to change a URI, make sure to return 301 status code. It means moving permanently if you get back to those status code names. And then try to also offer the new URI in the header for the developer to also see, okay, now I should go with that direction. And there are some tips actually you should consider for naming your API-based URL. First, try to avoid using www. It's not very nice to mention, and there are like 4 extra characters. Why should you? And try to keep it simple. And well, it would be nice to also use subdomains such as API. That's a good offer instead of like having a category name here. And it would be possible to also use different domain as well. Why not? Because it's not a website that actually users are gonna go and use. It's the API-based URL that developers actually are communicating inside of their applications with your API. And here we have some API endpoint tips. As we said, use plural nouns to identify resources. Here you have items instead of item, and you have people instead of person. And do not use verbs for resources, like get a student list. Remember, this is actually this is not SOAP, this is REST. So it's much nicer to follow REST patterns. If you remember, SOAP was like this kind of functions being called. And yeah, it would be nice to also manage these resources with a resource. So the students, they enrolled in some courses, so that would be a nice endpoint for that purpose. Here are some links where you can go and find more about this material that has been mentioned here. Make sure to send us feedback, ask for new material if I wasn't including something that you are looking forward to. We have this functionality of mini lessons now that I can time to time add new material to the course as well. So it could be more flexible and based on your demands and needs. And yeah, that was the whole material for the second part as our intermediate part of the course. Thank you for your consideration, and looking forward to see you on the last part of the course, which is advanced part. Have a nice day or evening.